Today is day 2, and our lesson topic is line of best fit. Go ahead and take a minute to set up your Cornell notes, and feel free to pause whenever you need to. How do I determine a line of best fit for a set of data? So to start today, we're going to take a look at a warm-up problem. And our warm-up today says to make a prediction. So I want you to go ahead, use the graph to make these two predictions. How many sandwiches can you make in 10 minutes based on the data you are provided here? And how many sandwiches can you make in 15 minutes? All right, so one way to do this would be to just kind of eyeball it. And I'm going to take, let's see, purple. And using my mouse pointer here, I'm going to start at 10 minutes because that's the first question. How many sandwiches can you make in 10 minutes? We see the independent variable is time, number of minutes. The dependent variable is the number of sandwiches that you can make. So if I go to 10 minutes and I were to make a dot, I want to try to figure out where, just like in our activity on last week, where we had to try to figure out where the scatter plot would go through. Is it right here? Is it right here? This might be actually a little bit better. If we look at the trend in the data, it looks like it's trending upward. And if this trend continued, kind of zigzagging back and forth a little bit, I would say somewhere right in these two areas, one of these two, right, would be pretty appropriate. I'd say maybe the higher one. So let's say 10 minutes would probably be 10 sandwiches. How about for 15 minutes? Let me switch to, let's do red, I guess. Make sure my dot's big enough. So 15 minutes. Again, I'm starting on my x-axis for time. 15 minutes. I'm going to follow it up until I feel like it's kind of in line with all the other data points, except for, let me go ahead and get rid of that one so we don't get thrown off by what that looks like. So again, 15 minutes. I'm just going to put a dot in there for now, and we'll move it. To me, that looks like it's maybe a little bit too low. It's not quite in line with everything else. I might need to go up a little bit. Let's go up one more sandwich. That looks pretty good. If I went up one more, it might be a little too high. So I'm going to actually go down one more, and I'm going to put it right in there. So 15 minutes, I'm going to say is 14 sandwiches. And 10 minutes we had was 10 sandwiches. So your estimate should be close to that. If it wasn't exact, that's okay, because we aren't actually performing linear regression right now by calculating anything. We're just kind of performing a linear regression by looking at a trend. And that's part of this process is looking at, well, what should my answer look like? What should it be, or what should it be close to? And that's all we're doing right now. So we're looking at a trend in the data, and we're trying to estimate to the best of our ability if that trend continues. And we don't know if that trend does continue. So we are gonna start with, I gotta go back, excuse me. The first main idea is line of best fit. So what is the line of best fit? It's also something that's called the trend line, so also known as trend line. So if I say line of best fit or line of fit or trend line, I'm really referring to the same thing. It goes by many names. So your line of best fit is really just a line that best shows the relationship of a data set. We kind of use that imaginary line of fit in our warm-up on the previous page, where we're just trying to figure out, if this trend continues, this invisible upward trend, where would we place our dots? Okay, so the line of best fit is just that. It's a line, a straight line, by the way, not necessarily straight across, but just a straight line from one end to the other that best shows the relationship of a data set. So we're going to just take a few examples. This is going to be a nice short one today. Look at a few examples and draw our own line of fit. So it says draw a line of best fit, or a trend line, that shows the relationship of the variables. So I'm going to go ahead and grab my straight line drawer so I can draw it nice and straight and then not freehand it. And on this first scatter plot, I can see that I'm comparing temperature with the amount of sales for some type of product, I guess. And I can see that on the lower side of the temperature, so the smaller or lower the temperature is, 12 degrees Celsius, we have sales that are around $200. If we go on the upper end of the temperature, so as it gets warmer out, the sales are much higher in the $500 to $600 range. So I can see that as the temperature is increasing, so as the temperature goes up, the sales are also going up. In terms of a line then, I want to have a line that kind of matches that data. And a good trend line or line of best fit is going to be one that, think about it as it goes through the data, but you try to get as many points as close to the line as possible. It doesn't mean that the points have to be on the line, because there is no way to draw a line that goes through all of these points. That would not be a single line from left to right. It would have to be like some jagged line or a collection of lines, and that's not what a trend line is. So what I'm doing now is I'm just adjusting the ends to try to make, see if I go down here, now almost all the points are above the line. I don't want that. If I have too steep of an angle, all my points are below the line. And even if I get it where it's, there's a couple of them above, but some of them below, look at it as, you know what, there's this point right here that's actually a long ways away from the line. If I follow it straight up, that's what we always want to do here, is go straight up or straight down to get to the line. These points are all really close, but this one down here is a long ways away compared to how close the others are. So I'd want to pull it down towards that other point a little bit. So now this is closer. Some of these other points are further away than they used to be, but you know what? They're not any further away than this one is. So I'd say that's a pretty good line of fit right there. In my second example, it looks like we are, man, that is hard to read. It's a process input on the independent axis, and the dependent variable is quality something. I can't even read that. Quality characteristic. Some quality characteristics measured with those values on the y-axis. But what we're looking at is all little green dots here. That's our scatter plot. Those are the different data points that we have. And as the process input starts on the lower side, on the left-hand side, we see that the quality characteristics are quite high. It's the highest values it has. And as the process input increases, take a look at where these data points are. They're down lower than these points up here were. Okay, so we're seeing it starting up high, and as you move across the graph, it's kind of going down. So we want to draw a trend line or a line of fit that kind of matches that. And this data is much more scattered. So even if I draw a line like this, I'd say that's not a good trend line. Yeah, it kind of matches what's going on with the data. It's kind of in between the data. But look at how many more data points are on one side of the line. That's way too many. We got to balance that out a little bit. So we're going to go ahead and move that up just a little bit. I like the angle. The angle kind of matches what's happening here on the scatter plot itself. Now I want to go ahead and just stretch this out to the ends, all the way on both sides. So that's about as close as I can get it, because even some of these points out here are, if you go straight down to the trend line, that's a long ways away compared to the other ones. But if I move my line up, some of these other points are actually going to be a long ways away too. And that's because the data is so spread out. It's just kind of hard to make this fit. So I'd say that's probably the best line we can get. Now, the other thing I want to talk about is representing if they're positive or negative trends. So our trend lines have slopes, right? On the first example, we saw that as the temperature increased, right, we had lower temperatures to higher temperatures, the sales also increased. The line was rising, it was going up. So this line has a positive slope, therefore it has a positive trend. Our second example here, this time we started up pretty high. We had higher values on the dependent variable. And as we moved to the right on the graph, as we kind of finished up, we went much lower on our graph. So the dots kind of went down in a downward direction. So our line has a negative slope, therefore it has a negative trend. So positive trends increase, negative trends decrease. Let's look at two more. And before I go through it, I want you to think about where you would place your line. And I know it's hard because you're not going to be able to draw this, but I just want you to kind of visualize it and think about, where would you draw your trend line? All right, so taking a look at our first example, it looks like we're comparing weight on the x-axis to miles per gallon. So I think this is referring to vehicles, because we have the different, like 4-cylinder, 6-cylinder, like a V8, vehicle. So we have different, the 4 cylinders are the blue dots, the 6 cylinders kind of in the middle, and the V8s down here on the right, where those are the heavier vehicles. Probably, I'm guessing these are supposed to be in thousands, like 2,000 pounds, 3,000 pounds, 4,000 pounds. And then they're miles per gallon. So obviously the lighter the vehicle, the better mileage you're going to get. The heavier the vehicle, your bigger trucks, for example, your V8 engines, you're going to get lower gas mileage, miles per gallon. So what we're seeing here is we are seeing that the data is starting up high and it's ending down low. So for a trend line, I want to make sure that I match that. I kind of start up here by these dots. I'm going to start way over here on the y-axis. Whoops. And I'm going to move down in this direction. Now, the only problem with this right here is if I were to stop that, I'm ignoring these 3 points. I'm ignoring the pull that they have on your trend line. So I'm actually going to have to move this over just a little bit because I want to make sure that these points aren't too far away from the line. Even though I have a lot more points on this side now, it kind of balances out when I factor that there's fewer points here, but these are further away from the trend line. So that would be okay. And we're just eyeballing it. And we can see on this one that my trend line is going down. Whoops. So what we're going to do is we're going to say that that is a negative trend. On our last example, we're comparing weight by height. So we're looking at heights of individuals, weights of individuals, and each data point is a different person. So we're saying that somebody over here that has a lower height, in other words, is shorter, has a lower weight. Okay, it might be a younger child. Then we have this person up here that that's the tallest person we have because the height is the furthest to the right is probably, I don't know, 72, 73 inches, somewhere in there. That person's weight is the highest weight that we have out of all the data points here. So we're kind of starting low and we're moving up high in terms of weights. So for my trend line, I'm going to start down low. I'm going to kind of finish up high. And I'm going to look at that and say, you know what? I don't quite like that line. It's not bad, but all these data points down here are a long ways away from that line. I'm actually going to pull it down just a little bit. Okay, I don't mind the angle of it. Maybe even just to bring this back up a little bit. To me, that's all right. I've got about half of the points on each side of the line. I don't have any one single point that's really far away from the line. Some of the points are close, and that's going to happen. But none of the points necessarily have to be right on the line. Now, in terms of our trend, is it positive or negative? We started out low, and the line increased, or it went up, it rose, as we went from left to right. So we would definitely say this is a positive trend.